Yeah, a very good afternoon, students. Good afternoon, students. Can you hear me? Am I visible and audible? Pratyusha, Ashwin, and the Rifle students, can you able to see me and my screen? Let me know in the chat box. Okay. So today we are going to start with a new lesson. Okay, new chapter. So which is called as electrochemistry. Okay. So we have completed solutions lesson yesterday, and I hope you guys are learning that lesson, revising that lesson, and solving questions from that lesson. Okay. So today we are starting with a new chapter, electrochemistry. So coming to the introductory part of this electrochemistry, what is this? Can anyone tell me what is this? What is this, my dear students? You can see a picture no on the screen. What is that picture called? Battery. Very good. So it is a battery. Fine. Now, what about this? Is it possible? This is a mobile, and is it possible to run the cell without battery? Is it possible to run the cell without battery? What do you guys say? The answer is obviously no. Very good. Okay. So, how does this cell run? And the answer to this question can be explained by electrochemistry. Okay. It can be explained by electrochemistry. So electrochemistry means, so we are separating this term into two, electro and chemistry. So it deals with the interconversions between electrical energy and chemical energy. Okay. So it deals with the interconversions between electrical energy and chemical energy. So electrochemistry is the study of production of electricity from energy released during spontaneous chemical reactions. Okay, it is study of production of electricity from the energy released due spontaneous means continuous. When a chemical reaction is happening continuously, some amount of energy will be released, okay, and that is producing the electricity. The study of this process is called as electrochemistry. And the use of this electrical energy to bring about some chemical transformation, including non-spontaneous process. Okay, so all the reactions are not spontaneous. Some reactions are non-spontaneous in nature also. Okay, so including those process, the electrical energy which we are producing, that can be converted into chemical energy also. Okay, so the interconversion, study of interconversion of chemical energy and electrical energy is called as electrochemistry. Okay, so chemical energy is getting converted to electrical energy here. Got it? So now, if you see to the batteries and fuel cells, they convert chemical energy to electrical energy. So that is the role of this batteries and fuel cells. So that is what is happening inside the battery, and that's why it is possible to run the battery with this cell. Because inside the battery, we are converting the chemical energy into the electrical energy, which is being used in our day-to-day life in mobiles and everything, etc. Okay. Now, this electrochemistry is important for creating new technologies which are eco-friendly because of more efficiency and less pollution. Okay, so very, very important. In the many other in all the technology industries, you can see they are giving more importance to electrochemistry because of eco-friendly. Okay, so we can efficiency is more and pollution is very less. So because of these two reasons, the importance is more importance is given for the branch of electrochemistry in the technology. Okay, now this is the introductory part of this electrochemistry, and Here in this lesson, we will be dealing with mostly the redox reactions. Okay. So can anyone tell me what is a redox reaction? What is meant by redox reaction? Any idea for anyone about redox reactions? Or you can give me the definition for redox reaction also. Have you heard of this redox reaction term in your class level? If you have heard of this term, you can give me the answer, definition in the chat box for redox reaction. So none of you know about the redox. Okay. So okay, very good, Ashwin, very good. Great. So redox reactions are the reactions in which both reduction and oxidation taking place simultaneously. Okay. So redox reaction is reduction and oxidation taking place in a reaction. Now, what is meant by reduction? What is meant by reduction? So, the definition for reduction can be explained in four different ways. So, the first thing is gain of hydrogen, or the system which contains less electronegative atom is called as reduction. Okay. Then is loss of oxygen or more electronegative atom, and gain of electrons and the decrease or decrement in the oxidation number. So these four are the definitions for reduction. So here in the examples you can see nitrogen is reacting with hydrogen to produce NH3. Okay. So here we have only N2, but in the product side nitrogen is bonded with hydrogen also. Means nitrogen has gained the hydrogen. Okay, means it has got reduced. So here in nitrogen, if you see the oxidation number of nitrogen is 0. And here for nitrogen, it is -3. So there is decrease in the oxidation number. There is decrease in the oxidation number, or we can say the addition of hydrogen has happened in this reaction. So that's why these reactions are called as reduction reactions. Okay. And in the second example, you can see the loss of oxygen. So initially we have CO2O, copper oxide, cupric oxide, and from this compound, oxygen has been removed. It has been lost, and the copper oxide has been converted to only copper. So the removal of oxygen is called as reduction. Okay, or we can say it in terms of electron transfer concept also. So according to electron transfer concept, gain of electrons are called as reduction. So here you can see the ion is having +2 charge. When it gains 2 electrons, it is getting converted to 0. Okay. So there is decrease in the oxidation number from +2 to 0. Means it has gained electron and it has got reduced. Okay. Clear? So here we have an iron block. Here we have an iron block. So iron atoms are forming that block, and if one of the ion loses its 2 electrons to the surrounding, then it will be converted to iron 2 plus, means it has got oxidation. Otherwise, if iron 2 plus takes 2 electron, it will be converted to iron atom. Okay. So we have four definitions for reduction. One is loss of oxygen, the other one is gain of hydrogen, gain of electrons, decrease in the oxidation number. Okay. So this is reduction reaction. Coming to oxidation reaction, does the opposite of reduction. So loss of hydrogen and gain of oxygen. So here in this reaction, you see, we have H2O in the reactant, but in the product, we have only oxygen. So the hydrogen has been removed. So the loss of hydrogen from the compound leads to the oxidation of the compound. Okay. So in H2O, the oxidation state of oxygen is -2. In O2, the oxidation state is 0. So it is going from negative side to positive side, -2 to 0. Okay, means it is called as oxidation. Okay, and in this example, you see we have a metal magnesium and oxygen has been added. So the magnesium has gained the oxygen. So the gain of oxygen is called as oxidation. So in the reactant side, the magnesium oxidation state is 0, and in the product side, the magnesium oxidation state is +2. So it is going from 0 to +2. So there is increase or increment in the oxidation number. So it is called as oxidation. Okay. And the loss of electron is called as oxidation. So copper metal is losing 2 electron. Copper metal is losing 2 electron and it has been oxidized. So from 0 to +2. Oxidation state is changing from 0 to +2 means oxidation is happening here. Okay. So any doubt from the oxidation and reduction? So let me summarize this and show you in the next slide. So here you can see the 4 definitions for both oxidation and reduction. Oxidation is loss of electron and reduction is gain of electron. Oil rig, OIL-RIG. Okay. Reduction is gain of electron. So any doubt from the redox reaction part, students? Do any of you have any doubts from the redox part? So in this whole entire lesson, you will be dealing with this redox reaction. So you should know what is reduction and what is oxidation. So just I'm recalling these two for you. Clear? Shall I move on to the next slide? Shall I move on to the next slide? Is everything clear and okay and understandable for all of you who are watching here? Yes, very good. Now, next I'm going to discuss about the oxidizing and reducing agents. Oxidizing and reducing agents. So we have one reaction and the oxidation state of each element has been calculated. Okay, and for this copper, it is +1 and hydrogen is having 0, copper 0 and H2O has +1 state of hydrogen. Okay, so copper has been converted from +1 to 0. So there is decrease in the oxidation number. So it is reduction. And hydrogen is going from 0 to +1, means increase in oxidation number. So it is oxidation. Now, who is the oxidizing agent? The one which is accepting the electron is called as oxidizing agent. When it accepts the electron, what will happen? Reduction happens. When something is accepting an electron, reduction will happen over there. Okay, reduction will happen over there, and that particular compound is an oxidizing agent. This particular compound is an oxidizing agent. So here if you see Cu2O is undergoing the reduction, so it is an oxidizing agent. And reducing agent means it helps in the reduction of other species and it undergoes oxidation process. Hydrogen is going from 0 to +1. There is increase in the positive charge, means oxidation. Okay, it is oxidation. So hydrogen has got oxidized and the copper oxide got reduced. So is this clear for all of you? Do any of you have any doubt from the definition of oxidation, reduction, and oxidizing and reducing agents? Yes or no, students? Shall I move on to the next topic? Okay. So the next is a question for you. Okay. So I will give you 3 reactions. You have to identify the oxidizing and reducing agents in the following reactions. So take the first reaction. Take the first reaction and tell me which is an oxidizing agent and which is a reducing agent. So here is a reaction for you. Tell me which is oxidized and which has got reduced. What is the oxidation state of sulfur in H2S? What is the oxidation state of sulfur in H2S? So here S is taken as X and for each hydrogen +2. So it is +2 plus X equal to 0. No, sulfur is not having +2. It is X is equal to -2. X is equal to -2 and hydrogen it is +1. And for chlorine, it is 0, it is a molecule. And for HCl, it is H plus and Cl minus. And for sulfur, it is 0 because it is present in its elemental form. Okay. So these are the oxidation numbers of each elements. Okay. Now, chlorine is going from 0 to -1, means it is getting reduced, and sulfur is going from -2 to 0, which is called as oxidation. Okay. Now the oxidizing agent is called as chlorine and the reducing agent is called as H2S, hydrogen sulfide. Okay. Now I'll take one more reaction for you. Try the answer for this. Find out the oxidizing agent and reducing agent in the given reaction. So to find out that, you need to calculate the oxidation number of each element in the reaction. So find out fast, what is oxidation state of iron in Fe3O4? Oxidation state of iron in Fe3O4. 8/3? No. It is +3. Okay, it is +3. Okay, for oxygen it is -2. Very good. So here in Fe3O4, iron is having two oxidation state. One is +2 and the other one is +3. And aluminium and iron, they are in elemental state, so 0. When you go for Al2O3, aluminium will show +3 and oxygen will show -2. Okay. So now aluminium is going from 0 to +3. So it is being oxidized, and iron is going from +3 to or +2 to 0. Means it has got reduced. Now who is the oxidizing agent? Oxidizing agent is Fe3O4 and reducing agent is aluminium. Okay. So this is the answer. What about this reaction? Find out the oxidation number fast for all the elements. Very easy, no? What is the oxidation state of each element in the compound? What is oxidation state of sodium here in the given compound, my dear students? The given reaction. For sodium, it is 0. Very good. And for hydrogen also, it is 0. And in sodium hydride, sodium has +1 and hydrogen has -1. Very good. So it is an hydride. So hydrogen will have minus charge. Okay. So hydrogen is going from 0 to +1 oxidation, and sodium is going from 0 to, so hydrogen from 0 to -1, sorry, it is reduction, and sodium is going from 0 to +1, it is oxidation. So the one which is undergoing the reduction, that is an oxidizing agent. So H2 is an oxidizing agent, it has gained electron, and sodium is the reducing agent. Okay. So this is how you have to follow the oxidation or the oxidizing agent and reducing agent from the given reaction. Okay. So now let's move on to the next topic, which is electrochemical cells. This is called as electrochemical cells. Now, so students, do any of you have any doubt from the things that we have discussed so far? From the oxidation reduction and from oxidizing agent and reducing agent. Is everything clear? So you won't make any mistakes in the upcoming classes, no? So you're all thorough about the oxidation reduction part, right? Yes or no? Do you want me to explain anything once again? Or is everything okay? Okay, fine. Now we are moving on to electrochemical cells. So this is a device which converts chemical energy from spontaneous redox reaction to electrical energy. Okay. And that device is called as electrochemical cell. It is converting chemical energy to electrical energy. And this cell is called as electrochemical cell. So these are also called as galvanic cells or voltaic cell. Galvanic cells or voltaic cell. So here you can see the setup. This is the setup. Okay. And in this device, if you see, have you all seen the device? Have you all seen the device? We have two beakers, and then both the beakers, one rod is being dipped, and both of them are connected to a salt bridge. I will explain those things for you later. Okay. So now we have this setup. So in this device, the Gibbs energy, already we might have studied this in thermodynamics lesson of class 11, no? So in this device, the Gibbs energy of a spontaneous redox reaction is converted to electrical energy first. What it is doing? The redox reaction is getting converted to electrical energy first. Means the electrical energy and Gibbs free energy relationship is delta G is equal to N F E naught. Delta G is equal to N F E naught, or E we can say. Okay. So where delta G is the Gibbs free energy, N is the number of moles, and F is the Faraday's constant, and E is the standard cell potential. This is standard cell potential. So this formula is very, very important. Okay. So only if delta G is coming out to be negative, I mean, or less than 0, it is the reaction is spontaneous. If delta G is equal to 0, then the reaction is non-spontaneous. So it should be what to say, in between 0 and negative. Okay. So only then the reactions are called as a spontaneous reaction. Okay. Now, coming to the uses of this electrochemical cells. So it is used mainly for running a motor or other electrical gadgets like heater. Heater you all might have seen now. This is a heater. So to run this, we need this type of electrochemical cell. Okay. Or fans. Fan. No fan, no. So to run this motor also, electrochemical cell is used there. Okay. Etc. Now, the description, coming to the description of this electrochemical cell. So to describe this, we are taking Daniel cell as an example of galvanic cell here. Okay. Daniel cell is used here. The cell reaction for this Daniel cell is zinc plus copper 2 plus giving zinc 2 plus copper. Okay. So here you can see zinc is going from 0 to plus 2. Copper is going from 0 to, plus 2 to 0. Okay, the oxidation state of the metals or the elements are 0, right? So we have to substitute 0. So we have to put 0 there. So zinc has been oxidized and copper has got reduced. So these reactions, these type of reactions, they occur in two different portions of the Daniel cell. This occurs in two different portions of the Daniel cell. Okay. Just give me a second. Yeah, two different portions of the Daniel cell. Now the reduction half reaction occurs on the copper electrode. This reaction, the whole reaction is getting converted into or divided into two. One is called as oxidation half reaction and the other one is called as reduction half reaction. So the reduction half reaction occurs on the copper electrode while the oxidation half reaction occurs on the zinc electrode. These are called half cells or redox couples. Okay, redox couples. So in the given reaction, you might have noticed that zinc has got oxidized to zinc 2 plus. So this is oxidation. This is oxidation because it is going from 0 to plus 2, no? So it is oxidation. So two electrodes are there and this is occurring in the zinc electrode. Okay. And each half cell consists of a metal rod which is called as electrode dipped into an electrolyte. Electrolyte means we can say this as electrolyte or electrolytic solution. Both are same only. So we have one solution and that is called as electrolyte or electrolytic solution. So the electrodes are dipped inside those containers only. Let me show you the picture. So here you can see we have two beakers. Okay. In both the beakers, two metal rods which are called as electrodes are dipped inside that. Okay. So the right side electrode is called as copper and the left side electrode is called as zinc. Got it? So Students, do any of you have any doubts from the things that we have discussed so far? Any doubt? Is everything clear and okay, fine for all? Shall I proceed? So we have discussed the introductory part, and now we are in the electrochemical cell part of Daniel's cell. Yes. Okay, students. So here in the Daniel cell, we have two beaker and there are two electrodes dipped inside the electrolytic solution. Now, the two half cells, we have two half cells, no, oxidation and reduction. Those two half cells are connected by a metallic wire through a voltmeter and a switch externally. So we have two things here. One is the voltmeter. So this is the voltmeter and this is your switch. Okay. So these two, they are connected by a metallic wire externally. Okay. And then what is happening here? The electrolytes, which are called as electrolytic solution of the two half cells, they are connected internally through a salt bridge. So you see the salt bridge here. So this is the salt bridge. So kind of inverted U-shaped thing. Okay. So it is a salt bridge. So the electrolytic solutions which are present inside the beaker, they are connected internally through the salt bridge, and the electrodes are connected externally through voltmeter and switch using the external circuit. Okay. Now, I'm going to discuss some information about the salt bridge. Okay. So we'll go with that. First of all, salt bridge is a U-shaped tube containing a chemically inert salt like potassium nitrate, potassium chloride, sodium chloride. We can take sodium nitrite also. Okay. NaNO3 can also be taken. So you can take any type of inert salt. Okay. So that has to be, those salts has to be filled inside this U-shaped tube, which is called a salt bridge. Okay. So in all the salts, we have cation and anion. Okay. Mobility of cation. Mobility means movement. The movement of cation will always be equal to the movement of anion inside the U-shaped tube, which is a salt bridge. Okay. And this completes the electrical circuit and maintains the electrical neutrality of both the electrodes. Okay, so to maintain the neutrality only, we are using the salt bridge. And also it maintains the spontaneity of a cell reaction. Okay, for a reaction to be spontaneous, delta G value should be negative. So it is maintaining that spontaneity. Spontaneous means continuous, I already told you. So if a reaction wants to happen continuously on its own, so it has to be maintained, no? So this salt bridge is maintaining that spontaneity of all the cell reactions. Okay. So these are the very important informations you should know about the salt bridge. So if you want to note this down, you can note it. If you have completed, type S in the chat box so that I can proceed to the next slide. Shall I proceed with the next slide? Have you all completed this part? Say something, students. Do you have any doubts? Do we have any doubts from this till this slide? Do any of you have any doubts from this till this slide? All of you are clear about the salt bridge and the circuit, the Daniel cell circuit. Okay, okay, students. Okay. Now let's continue. Let's continue. Let's start with the reduction half reaction first. So I have given you the redox reaction. Okay, the net redox reaction we have seen. So inside the system which I have shown you in the previous picture, the two reactions are happening, oxidation, reduction, half reaction. So in the reduction half reaction, we have copper 2 plus. Copper 2 plus will gain 2 electrons and it will be converted to copper. And in the oxidation half reaction, zinc will lose 2 electrons and that zinc metal will be converted to zinc 2 plus. So these are the two half reactions. Okay. Now here, Now we are going to study the working process of this Danielson. Okay, so far I have been explaining you the experimental setup. Okay, so now we are going to study about the working process of the system. Okay, so first of all, there is a tendency of metal ions from the solution to get deposited on the metal electrode, trying to make it positively charged. At the same time, metal atoms of electrode have a tendency to go into the solution and make it negatively charged. Okay, so I'll show you the picture. Okay, before moving on to that, let me explain here also with the statement. So I have the beaker, right? So my beaker doesn't look good, but anyway, you guys adjust here, okay? So we have an electrolyte and the metal electrodes are dipped here, no? So the metal, there will be, so this is an electrolytic solution. Suppose if this solution is sodium chloride, so the solution will have Na plus and Cl minus ions. So which are called as metal ions in the solution. Okay. So the metal ions, sodium plus ion, which is present inside the solution, they will try to get deposited on the surface of this metal electrode. So this is the surface of the metal electrode. They will try to get deposited on it. Okay, trying to make it positively charged. So the same way, the other way around is also happening. Okay, so if this metal rod, let me take this metal rod as zinc. Okay, if I'm taking this metal rod as zinc, so what this zinc metal rod will do? So zinc metal rod will have zinc atoms. So they have the tendency to go into the solution. They have the tendency to go into the solution. Let's see now. Let's see. And now at equilibrium, what will happen? At equilibrium, so there is a separation of these two types of charges. We have a positive charge and negative charge. No, at equilibrium, there is a separation of these two types of charges. Hence, depending on the tendencies of the two opposing reactions, the electrode may be positively charged or the electrode can be negatively charged with respect to the solution. Okay. Now, the potential difference which is getting developed between the electrode and the electrolyte. So, we have the electrode and we have the electrolyte. The potential difference will develop between these two, which we call it as electrode potential, which we call it as electrode potential. So in galvanic cell, if you see, the oxidation half cell is called anode and it has negative potential with respect to the solution, whereas the reduction half cell is called cathode and it has the positive potential with respect to the solution. So if you go for the electrode potential value for all the oxidation half cell, which is called as anode, will have a negative value, and for reduction half cell, which is going to occur at cathode, they will have the positive values of E naught. Okay. So this is about the electrode potential topic, electrode potential term. Let me show this in the picture. So we have two rods. One is a positively charged rod and the other one is a negatively charged rod. Okay. So now I'm going to draw a line here in which, so this is a rod in which positive ions are there and here we have some ions which is present inside the solution, the same way with the other thing also. Okay. Now what does that blue color line denotes? So that blue color line is separating a similar type of charge on one side and the mixed charges on the other side. So what is that similar charge? So it is just the opposite of the charge to the metal rod. If the metal rod is positively charged, negative ions are moving towards that. If the metal rod is negatively charged, then the positive ions are moving towards that rod because only opposite charges will attract each other. No, so that's why this is happening. Clear? And this layer is actually the diffuse layer we can say. Okay, and this is the opposite charged ions adjacent to the surface, which I was explaining you now. Clear? So the similar type of ions which is present inside the solution, they will move towards the one type of rod which is opposite in charge to that. Got it? So this is the working process. So you can see this in this GIF. So we have two containers. In the first container, I am going to take a zinc nitrate solution, which is an electrolytic solution. And in the second beaker, I am going to take a copper nitrate solution. So inside the zinc nitrate, I have a zinc rod, which is anode. And in the copper nitrate solution, I have the copper metal as the rod, and which is the cathode over there. So anode is negatively charged and the cathode is positively charged. Okay, charges are very important. Anode is negatively charged and cathode is positively charged in case of Daniell cell. Okay, in case of Daniell cell. For all other electrolytic cells, it is the opposite. Only cathode will be negatively charged. Only for this cell, you have to study in this manner. Okay, now what will happen? Inside the zinc nitrate solution, we will have zinc 2 plus and NO3 minus, because zinc nitrate will be dissociated into its corresponding cations and anions in this manner only. So zinc 2 plus and NO3 minus is present inside the zinc nitrate solution. And in the same way, inside the copper nitrate solution, what type of ions will be present? Can you tell me? Can you tell me the ions which is present inside the copper nitrate solution? What are the cations and anion of this copper nitrate? It is copper 2 plus and NO3 minus. Copper 2 plus and NO3 minus cation and anion will be present inside the second beaker. Okay. Now, inside the salt bridge, I told that we will be having an inert salt. And here the inert salt which I'm going to use here is sodium nitrate. Inert salt is the sodium nitrate. So the zinc 2 plus, which is present inside the zinc nitrate solution, it will come, and the copper 2 plus ion which is present inside the copper nitrate solution, it will go and try to deposit on the copper cathode. So the electrons are moving from the zinc to the copper side. So from where does these electrons come from? It is coming from the zinc. So this is the zinc rod which has zinc atoms, So those zinc atoms will lose 2 electrons into the solution. Zinc atom which is present here, what it will do? It will lose 2 electrons into the solution, and it will be converted to zinc 2 plus. So those 2 electrons which has been released to the solution, that is carried here from the anode to the cathode. Okay, from the anode to the cathode. And what does this copper 2 plus do? The copper 2 plus which is present inside the solution, that will gain the 2 electrons which is coming from the zinc side, and it will be converted to copper. So this is how the reduction and the oxidation, or the loss of electron and the gain of electron concept is going on, or the redox couple is happening. Okay, in case of Daniell cell. You see here, in the salt bridge, we have Na plus NO3 minus ion. Clear for all of you? Do any of you have any doubts from this? Any of you have any doubts from this? All of you can able to understand, right? That how does the electron losing and electron gaining process is happening inside the Daniell cell? Yes? Electrochemistry is also a physical chemistry lesson like solutions. Okay. Okay. Fine. Now, coming to the next point, the number of galvanic cells can be constructed on the same pattern of Daniell cell by taking the combinations of any 2 different half cells. So here I have taken zinc nitrate and copper nitrate solution. Okay. Then the same way we can take some other electrolytes also. We can produce different types of half cells, and more number of galvanic cells can be constructed in the same pattern which we have seen. Got it. Now let's do some multiple choice questions from the topics that we have discussed now. Okay. So moving on to the first question for you. The first question says that a cell in which electric current is produced by an oxidation reduction process is called option A, voltaic cell, option B, reversible cell, option C, concentration cell, and option D, standard cell. Find out the cell in which the current, electric current is produced. Means electricity is produced by oxidation reduction. Oxidation reduction is a chemical process. Electrical energy is produced by the chemical energy. Which is the correct answer? Very good. It is the voltaic cell. Okay, electric current is produced by the chemicals through oxidation and reduction. Very good. Moving on to the second question. The function of salt bridge in an electrochemical cell is. So we have discussed now. Try to recall that and find out the answer. Option A, to prevent the mixing of the electrolyte in two half cells. Option B, to complete the circuit. Option C, to maintain the electrical neutrality. Option D, all of the above. Option C. No, the correct answer is option D. Okay. So you can take these 2 points also. So to prevent the mixing of electrolyte into two half cells and to complete the circuit, all the three given statements are the function of the salt bridge. Okay. The first 2 points I did not give you in that slide. No, you can take this also. So coming to the third question, shall I move on to the next question? Shall I move on to the next question? We'll do one more question. Are you guys writing the points here? Okay. Daniel's cell is shown as. Daniel's cell is shown as. Which is the Daniel cell here? In Daniel's cell, zinc will be converted to zinc 2 plus and copper 2 plus will be converted to copper. No, no, no. Correct answer is option B. Okay. I'll tell you why option D is not the answer. Okay. So, in D also we have the reduction oxidation part only, but you have to represent the one which has got oxidized first. Zinc has got oxidized, no? So the reaction which is occurring at anode has to be represented first, then only the cathode reaction has to come. So that's why option B is the correct answer. Is it okay? Is it okay for JNB Anam? Students, is it clear now? I will explain this in tomorrow's class in detail, okay? So tomorrow I will discuss the IUPAC convention, like how to represent a cell, okay, using the IUPAC convention. So in tomorrow's class, you can get a clear idea about it, okay? Like why we are putting only one line in between zinc and zinc 2 plus, and why I am putting two parallel lines between zinc 2 plus and copper 2 plus. Those things I will explain you in the tomorrow's class, okay? So now I hope this session is very useful for you guys. Do any of you have any doubts from today's class, from the introduction, redox reaction, and from the electrochemical cell concept, which is a Daniel cell? Is everything okay? So initially, we will have some theory part kind of thing like this. Later on, we'll be studying the formulas only. Okay, where you have to apply all the formulas which you are going to study into the problems. Okay, we will solve more number of problems like we have solved in the last topic, solutions lesson also. Okay, Then fine. Thank you, students. Thank you so much for listening. To meet you all in the next session. Take care. Thank you.